Hi guys, welcome to Learning Electronics Repair and part 2 of the PCBWay sponsored video on the inverter project. This is a 50 Hz inverter, 12 volts in, 240 volts out, and this is a project from PCBWay.com website. This is a user submitted project. There are many interesting projects on PCBWay, and I believe there's a lot to be learned by building these projects. Sometimes they work exactly as you would think, sometimes maybe not, and if not, then you can learn a great deal by the time you figure out how maybe you can improve the project, for instance. So in part 1, I built this inverter to find that the outputs on this IC CD4070 are not driving the MOSFETs. One is switched on and one is switched off. It should oscillate. But the chip is oscillating. It has an oscillator output on pin 13. It is oscillating at the expected frequency. It just isn't driving the MOSFETs from the other outputs on pins 10 and 11. The way this chip works, it is a multi-vibrator. That's what this circuit is called. I would call it an oscillator. There must be some historic reason why it's called multi-vibrator. Okay, but this capacitor and this variable resistor set the frequency, and on pin 13 we can see a square wave at the frequency set by these. Pins 10 and 11 actually come through a frequency divider, so these run at half the frequency of the main oscillator output on 13, and they switch on and off alternately. So first this one is on, this one is off, then this one should go on and this one is off, and vice versa. And this is what's not happening. I then tried 3 other chips, all doing the same thing, so it does seem very strange. I would have a whole batch of faulty chips, for example. So I then built another circuit. This is not the same. It doesn't have the MOSFETs, you can see. This is an LED flasher. So again, it has a capacitor, a variable resistor. This is set to run at a lower frequency with a higher value capacitor, and it should flash the LEDs alternately. Again, it doesn't. The oscillator runs, but the outputs on pins 10 and 11 don't work. Sometimes it will go from one state to the other and stick there, but that's what we get. So of course, then I published the video and a lot of you guys had a look, and there's a lot of suggestions, and I did say in the next part we will take the suggestions and we will try them to see if we can figure out why this circuit isn't working. Just out of interest, these 2 chips here are not connected to anything. I was just sticking them there while I was making some tests with them on a multimeter to stop them moving, so they're actually not connected, they just stored there if you like. Okay. And as well as the 4 chips I have here, 1 on here, 3 I've tried on here, and I've actually tried 3 in here, I have 6 more, so I have a few more of these to play with. In this video, we're going to try the suggestions that people made to see if any of them have fixed the problem. We'll do these in the order of what's easiest first, not in the order that they were posted, or the most popular suggestions, or even the ones I think are the most likely to have an effect. We'll just get the easy ones done first, and if none of those solve the problem, we'll work on to the more difficult ones to do. But we'll work through them all, and we'll either fix the problem or we won't, okay? But just before we start, a message from today's video sponsor, PCBWay. PCBWay is a great place for all your PCB needs. Whether you just want to make a prototype, get a few PCBs for your own project, or order large runs of PCBs, they can provide the service you need. It's actually very simple to use this website. I found it a little bit daunting at first. The basic process is that you design your PCB in any of the popular PCB design programs. It doesn't really matter which one you use, whatever you prefer, and you'll end up with a Gerber file. That is a zip file in actual fact that contains all the information that is needed to actually manufacture that PCB. And to get your PCBs, simply from the home page, we're there now, quote now, quick order PCB, add your Gerber file, Select the file and open. And there we can see the PCB, a layout of it. We can also have a look, if we like, at the 3D image of that. But to order the PCBs now is very simple. We just make a few choices. For example, is this a two-sided board, single-sided? It will normally pick this up from the Gerber file anyway. In this case, it has done. I normally go with the default settings. If you like, you can choose thinner PCBs. You'll see the price changes slightly sometimes. You can have different colored PCBs. So these are the various options you have. You then select your country. In fact, if you create an account and sign in, all this information will actually already be there. My country is Spain. I have a lot of different options for shipping. The price generally depending on how fast they are. If I'm not in a rush, well, I can use the cheap one, $4.36, apply that. And you can see I can get 5 PCBs shipped to me for just under $10. There is a discount code in the description to this video, which will give you $5 off your first order. So give them a try. As well as PCBs like the one we've just ordered, if you want to have your PCB populated, you can also select the assembly service. You then upload the bill of materials and the pick and place file. These once more will be generated from your PCB design software, and you can have your boards either fully populated or partially populated, one or both sides depending on what suits your requirements. If I was now to save this order to the cart, what will happen is the technicians at PCBWay.com will check the order. They will make sure that the PCB can be manufactured, that there's no errors in the file. This is not to say that you design the circuit correctly. This is to say that the spacing between various components doesn't break any minimums, the width of tracks, etc. It's to prove that they can actually manufacture the PCB that you uploaded the file. Once they've done that, they will confirm the price. Normally it doesn't change, and you can then order the PCBs. They will take, depending on the service you use, a few days. I'm using the lowest priced option, so 5 to 6 days to build. You can have them built, if you like, within 48 hours or 24 hours. You'll see you pay considerably more for that, but again, the choice is yours, and your PCBs will be shipped. Okay, so using PCBWay is as simple as that. Guys, give them a go. I've always been very pleased with the quality of PCBs that I've ordered, and I'm sure you will be too. Okay, so here is the original video. I will link it in the video description to this one if you would like to watch it first to catch up with where we were. Let's see what we have in the way of suggestions. We have a comment here from Tiggy Dorset. He's saying, check the markings on the chips, see if they've been painted on, for example. He gives me a case where he had a painted chip that was found to be fake with 2 good ones after comparing meter readings with a known good chip. I don't have any known good chips, but I did check on 3 of them and they all read the same. Okay. And similar, Fubar the Fat Penguin. Try rubbing the chips with IPA. If they repainted, which is going to happen, the paint might come off. If nothing happens, you won't know if they're good, but if it does come off, you'll know they're bad. Okay, that's fair enough. So let's try that first. Well, here are the chips. It looks like these are effectively all painted. I don't feel any kind of like engraving as though they're engraved into the chip. Okay, I don't have any other of these chips apart from these 10 that I bought from AliExpress. This is another chip in the same series, and the logo looks a little bit different. Again, these feel completely flat. They don't feel like they are engraved into the plastic at all, like they are printed. Okay. And there is a direct comparison between the markings, so we can see they look different. Now, I don't know if the other chips are working or good or bad. Anyway, they're simply ones I have in stock. I have a few more, so let's have a look. Well, these have a different logo again. Okay, there are definitely differences between these logos. Okay, that is a Philips one, completely different make. An XP, completely different make. So I can say that my chips are marked with a logo that looks different and a font that looks different from the other Texas Instrument ones, but I can't necessarily say if any are effectively more fake than the others. Yeah. Okay. Let's try rubbing this with some isopropyl alcohol. Well, I've tried rubbing that really quite vigorously and it doesn't come off. Okay, it does not come off. One thing I will notice that these ones have like a little U-shaped cutout or indent at one end. These have a dot that almost looks like it's been filled in with something. Okay. So in that respect, they are a little bit different. But these ones also have that kind of dot as well. Yeah, so it seems like these things vary a bit. Anyway, that has the U-shaped indent. So I don't think there's anything conclusive there at all, to be honest, but worth a try. What doesn't make a lot of sense to me is if these chips are fake, what are they? Because they operate basically in the same way that a 4047 would. If you connect a resistor and a capacitor between pins 2 and 3, it does oscillate and we see the output on pin 13. It works pretty much as you would expect. The only difference is, as I mentioned, that the other two outputs on 10 and 11 don't. Okay. Now, if there is a chip that actually operates in that way, then why not sell it for what it is? I mean, to make something fake worthwhile, you must be able to find something that you can spend a little bit of money to make it look like something else, to make extra profit. And I don't really get that in the case of these chips, but you guys, yeah, you tell me what you think, but it just doesn't logically make a lot of sense to me, at least. Having said that, I'm not an expert, of course, it's just on my own observation, but I don't really see the sense in it. More likely, if there is a problem with them, they could be a batch of defective chips of the right type, I guess. Maybe a load came out from the factory somewhere that didn't work, they were defective and they've been sold. So I think that's more likely than fake, but there you go. Comment more. Pixel waster. You could try the circuit at 3 or 5 volts. CMOS works from 3 to 15 volts, while TTL is 5 volts. It might work on a lower voltage. These chips are late stage kitchen remodels, counterfeited. I like it. Yeah, just look at the TI logo. So he is commenting on the logo. Well, we've had a close look. Make your own mind up on that one. So the original circuit, the PCBWay project, actually I was running this at 12 volts. This project I was running at 9 volts. That's because the original project I found online, which I did show in the other video, is set to 9 volts. I'm sure it'll work on a range. So let's try that. Let's try some different supply voltage and see how this responds. Right guys, I have the power supply set to 9 volts. Very close, 9.11 volts. Okay. And we can see that one LED is on, one LED is off. On the oscilloscope, we can see the output on this orange wire, which is pin 13. And that is oscillating. I'll just make this scope screen a little bit bigger. There you go. So you can see from the scope, it's running at about half an hertz, 571 millihertz, so about 0.5 hertz. We know it's actually running very slowly. It should be flashing the LEDs slowly. It's not. And the amplitude of the output on pin 13 is 9 volts. That's the supply voltage. So this is oscillating between 0 and supply voltage on pin 13. What voltage do we have on these LEDs? Well, the one that's on has 5.21 volts on it. Okay. And the one that's off is 0, which is what I would expect. So the output here is not actually being held up at the 9 volts. It kind of goes to like a sort of, not half, but 60% or something like that voltage. Yeah. I do know from checking earlier, and we will just check again, that there's no signal on this pin, maybe like little spikes. We can just check that though. So I've connected another orange wire to the output, which controls the LED, and we can see what's on there. And it's just high. We don't have any signal on there. Yeah, it's just high. 5.4 volts. Right. Connect back to the oscillating output on 13. And I'm going to take the voltage down now. So these chips should run down to 3 volts. Let's have a look what happens. I'll just try and set it, get my multimeter on, you'll see what we have. So supply voltage is now 3.06. We can see it's still oscillating on the scope. The LED is still on, so let's switch it off now, and we'll power it up at this voltage. Okay. So 3 volts, just fractionally over. Because it's such a slow oscillation, it takes the scope a moment to just pick that up, which it has done. And we can look at the output voltage, and it's 2.1. So again, about 60% of supply. I'll take the voltage up now to 15. These chips will handle that. I'm not sure without looking at the data sheet the maximum supply voltage, but 15 is not going to be a problem. So we'll go up to 15. Okay, and we see we have output. I think it says 15.8 actually, but 15.6 maybe is not totally accurate. And also think that little spike on the end of the rising and falling edge, which is probably my 10 times probe, just needs adjusting slightly. But yeah, 15 volts. So we know again pin 13 is going between supply and ground, and the LED now will have almost 9, so we get about 60%. We can switch it off, we'll switch it back on again. Okay, and that's what we have. So changing the supply voltage doesn't make any difference, but we can say that this chip will run between 3 and 15 volts, so it's not a TTL chip, for example. We have a few more easy suggestions. So Muddy 11111 is that a polyester capacitor, higher losses than the ceramic, and the example he's referring to the design on PCBWay for the shared project, the Easy One project. Yes, it is polyester or something like that, but the oscillator is actually running. This is me replying. And also on the LED flasher, so this is a circuit I found online from a respected site. It did use an electrolytic on that LED flasher circuit. Muddy 11 saying that the spec sheet calls for a non-polarized capacitor. It might be an issue, but again, it is oscillating, so that isn't the case. And I'm sure there's also no problem with the polarity on that capacitor. In fact, we can actually check that with the oscilloscope as well. We can easily check this. So I've disconnected the oscilloscope. I'm now going to connect it to the positive pin on the electrolytic capacitor, which is actually pin 3, which is the same place as one of the green wires that comes down to the potentiometer there. And we see in fact that this is oscillating at the same frequency as the output, same amplitude and in the same polarity, so the electrolytic is just fine in there, doesn't cause a problem. But because the oscillator was running, really we knew this anyway, I just thought it would be good to prove this, so there you have the proof. What else can we try? Try pulling out one of the MOSFETs. Maybe the gate ons are overlapping, so both MOSFETs are on at the same time. If that was the case, what would happen is that both LEDs, if you like, would be on at the same time. But I know this is not the case. He's referring to the original project. Bear in mind that this breadboarded example doesn't use any MOSFETs. On this circuit, on the original video, we looked at the gate on both and we found the same as we have here. One gate is being driven on and the other one is not being driven. So we don't have a case that both gates are on at the same time, both MOSFETs on at the same time, okay? So that isn't actually relevant to this problem, proven by the fact that this circuit doesn't work either, and it doesn't have MOSFETs. I think this guy's talking about my breadboard, pins 18 to 21 with rough. Okay. Ah, this one. So Max 886, he says the circuit you use is wrong. At 620 we see that both the astable and not astable inputs, we'll look at this on the datasheet now, are connected to the supply. Meanwhile, the datasheet reads astable operation is enabled by a high level on astable or low level on not astable input, or both. Try reconnecting the not a stable input to ground. This won't make a difference. I will do this, but read this again. A stable operation is enabled by a high on the astable input or whatever on the other input. It doesn't matter. If you've got a high on the astable input, then you have astable operation. The other one could either be low or high. It wouldn't make any difference, yeah, because this is an OR. Okay, but let's just look at that on the datasheet just to clarify this. Okay, so here, this is a block diagram for the 4047. Now, we have a number of inputs: astable, trigger, retrigger, external reset. This part of the circuit is working, so we have astable gate control, astable multivibrator, the resistor capacitor that set the frequency, and the oscillator out, and that works. What doesn't work for some reason is this part, the frequency divider. And you can see we have two outputs here. One is inverted on the other one, okay, and we have some signals that control this. So the operation we're using is a free running multivibrator, okay, and you can see here it tells you which pins go to VDD. This is your positive supply, and VSS, which is ground. So we can make sure for the free running, which is what we have, that we have these pins connected where they should be. Now, what the suggestion was made by Max was that we have this input 5 as high, and this one, which is the low input or inverted input, is also high. But the rule says that if one is high or the other, then it will work. And we can see from the example here that 4 and 5 are both connected to supply, okay? So that isn't what's causing the problem. That is normal. And somebody else comments further down that that is normal. It's more possible that there's a problem with this trigger thing, because these effectively are inputs to this frequency divider, okay, which is pins 9, 12, 8, 6. But again, it tells us here 9, 12, 8, 6. It tells us what should be on those pins. So let's just check them all to make sure we're happy. Let's check this then. So VDD, this actually means voltage to the drains. You'll sometimes see VCC, voltage to the collectors. This is your positive supply. So don't let that ever confuse you, okay? And we have pin 14, 15 volts, that's supply, and then 4, 5, and 6. So this is 6, 15 volts, 5 is 15 volts, 4 is 15 volts. And then VSS, voltage to the sources. This is your negative supply or ground in this single supply rail circuit, okay? You'll see VEE, maybe, that's voltage to emitters. You don't really see that one particularly often, but VSS you do see, okay? So 12, 9, 8, and 7. 7, well, it's saying 0.005, so we know we have a connection to that pin. That's ground. 8 and 9. 8 has the same. 9 has the same, and then 12, which is here, has the same. So we know those are all correct. And I hope now, Max, that you can see why the truth table or the logic is correct. Then it will put it into a stable mode. Another comment on the same topic from Peter RT3TU. Okay, you can see that. Asking about a stable and not a stable pulp to VPP or VDD, that's what fact it is. And then he goes on to say, oh, I should have read the comments before writing. So this has been discussed here. Thank you, Manticore, for pointing this out. I do think it's a little bit strange that these two pins are marked effectively, one is not the other. But as I commented, it's an or thing, yeah. Test the chip in the programmer. It has a test function, David Cotter. I don't know if, David, if you mean my EEPROM programmer has a test function, but I have 2 logic chip testers here I bought from AliExpress. I meant to make a review. I actually bought these, they were not sent to me. I never got around to doing it, so now as a perfect opportunity, we will do this if none of the other tests effectively give us an answer to what the problem is, okay? Hank W1562. Looks like the chips are fake or faulty. Have you tested all the available chips? No, I've only tested 4 out of the 10. I don't have any scrap boards with these on that I know of. Testing without the LEDs to check the waveform. Mail with a drawn code. Well, you can see the voltage supply to the 2 LEDs. I think that's a bit suspicious. I don't understand why it isn't in actual fact 9 volts, if that's the supply. Yeah, I think there's something a bit strange there. Manticore, yeah, fake or rejects. I'm thinking reject chips, because if we're going to say they're fake, then what are they? There's got to be some chip that's commercially available and cheaper that does what these do. Yeah. A bit about resistor color code, not really relevant. By the way, you don't need a website to get the color codes, just learn the color codes and then work them out. It's quicker. Yeah. Because strangely enough, before we had the internet, we could work out the resistor values from the colors. Yeah. NAF chips, but he says he understands one bad but not all of them. Yeah. I think it must be the circuit present correct. I don't know what you mean, Stephen. You didn't come back, so I don't know. You need to pull down on the gates. This is talking about the MOSFET gates Tesla Apple, but bear in mind that the breadboard version doesn't have any MOSFETs, okay? But what we could try doing is to connect a resistor to pins 10 and 11 to ground and another resistor to VDD supply, I don't know, a couple of like 10k resistors or something, see if it happens. You're not questioning the board. Oh, sorry, just watch your breadboard, is it? Yep. That kind of isolated that. So really that's about it. So the only thing we're left now with is maybe pull up and pull down resistors. Now, I don't believe they're needed in this circuit, but let's stick them in and see what it does. And testing these chips in a chip tester. Right guys, so I've taken the LEDs off. I've connected a resistor, these are 2k resistors, to ground and also to the supply voltage from pins 10 and 11. These pins were driving the LEDs through 470 ohm resistors, so they should be quite happy with this resistance. I'm just interested to see what we see output on those pins. Okay, let's have a look. So obviously there's no LEDs now, but we should see the thing oscillating on the scope as before. It is oscillating. Let's put the meter on, it's gone to sleep. So pins 9 and 10, sorry, 10 and 11, so 8.5 volts and 13.2. So they're in different states. One of them's 8.5, that's around about half the supply voltage. The other one is near to supply voltage. And we can just check that actually. So let's hit the scope. Okay, so that's the output, 15 volts high on pin 13. Pin 10, let's have a look. Actually reads a lower voltage than it did with my multimeter. Pin 11 is at 13.4. So it doesn't drive the outputs, okay? There's one more thing I want to test, which I thought of, and then we'll have a look at these chip testers. I've reconnected the LEDs. I may have them the opposite way round now. I didn't really check. The different one is lit up, but occasionally it did actually switch around before anyway. Yeah, still at about 2/3 of the supply voltage. 10, basically 0, okay. So what I'm just wanting to test is this problem to do with decoupling? So often you find a capacitor directly across the power to ground on these sort of logic chips, very close to the chip. And this is to stop spikes when the circuit's internally is switching, drawing different amounts of power. So decoupling capacitors are often these types, ceramic, 104, 100 nanofarads. I'm going to try and mount this directly across the chip, so as close as I can to the supply and ground pins. And let's see if this makes a difference. Well, this proved rather tricky, so what I've done is I've actually soldered the capacitor to the ground pin, and then I could get across to the power pin, so that's mounted directly across the chip. If it's going to work, that's the best place for it. Okay, I've connected the oscilloscope back up again now, so let's see what happens when we power this up. And it makes no difference, so I think that eliminates that. I wasn't sure it would, because normally you do this sort of things on things like microcontroller units and logic circuits actually switching very quickly, but I think it was worth a try, and I can say we've eliminated that. So really now we're down to testing the chips, and here are the IC testers that I've bought. So this one is marked KT152. Okay, it's like a little standalone tester, battery powered. I don't have any instructions with this, but I'm pretty sure I can find something online. So we have that. And we also have this one. So this isn't marked on the item, but on the bag it says TES200, that is the tester. Again, this is a standalone tester basically, it's not USB or anything like that. It has some buttons on. The display fits onto here. So I have those two testers. Now, I had a quick look. I got these from AliExpress. They were not very expensive. This is the TES200. Okay. I had a look to see which ICs this will test, and we have a list here. However, the CD4047 is not on the list. It doesn't test this chip, so that one's actually not going to help us in the case of this particular problem. The other one, which is the smaller one, this one, okay, similar sort of price. I think I paid less than that. I bought it a little while ago. This says also tests optocouplers and LM339 as well. Gives us a list of chips, but again does not test the CD4047. Okay, but it has various other devices. So neither of these are actually going to help us. The other IC tester I bought is this one. So this is a bit of a in progress. It comes as a PCB, and there are various adapter PCBs. You have to populate the board. So I was waiting for some displays. I now have the correct displays. I didn't have them. They are here. This is a Retro Chip Tester Professional. It's been here a little while actually. I am going to make a review of this. Again, I paid for this. I now have a later version firmware of that, so we can put the latest firmware on. I'm just waiting. I realise I don't have the module. This is a 12 volt module which goes here or here. One of two types. I forgot to order them, so once I get the module there, we can put this together. And we can try as well with this one. Now I have a feeling this will test these chips, but it needs one of the adapters to do it. So I'm going to have a word with Stefan. He's the guy who developed this. He's an independent developer. And if it does, we'll get an adapter. But that's not going to help us in the short term, okay? But later on, I'll order that. Next month or two, let's get this reviewed as well. So where does that leave us? Well, you know what, looking at IC testers, let's see if PCBWay have any projects on this as well. Yeah, I mean, more than one IC tester is a good thing. Yeah, let's have a look. Here we are on PCBWay.com once more in the shared projects section. I haven't seen any chip or IC testers, for example, like logic IC testers on here. But if we just put in tester, something fairly generic, and search, we'll find many things. Op amp testers, diode testers. You see lots and lots of things here. Some are quite specific to a particular purpose. Some are more generic. These are basically projects that other members of PCBWay have uploaded. Look, there's mine, or rather Detlef and myself, Mr. Bleep Reimagined, okay? I've built a few of these testers on here before, but there's many I haven't. So you guys, have a look if you've got a bit of time. Just go through. I mean, there are, from what I see, at least 9 pages, maybe more. Yeah, there is 9 pages. If you see something on here you think might be worth building, whether for the use of it or just out of interest, let me know, and I will ask PCBWay if they will send me some PCBs and we can use one in a future video. So where does that leave us? Well, I've tried all the things that you guys suggested, didn't really get anywhere with that. I've tried what I thought as well and didn't get anywhere with that. I think there's something very strange about those chips. I mean, the fact that the Q and not Q outputs go, well, when it goes high, it goes to a strange voltage of 2/3 supply voltage. My thought is defective batch of chips. And the only way to prove that now, because we don't have a tester, and let's face it, building that breadboard circuit, really, we did build a tester and it failed, is to order some more chips. So I'll get on and do that. You guys, if you're interested, get over to PCBWay.com in the shared projects. Let me know what you would like me to build, and we'll have lots more fun on learning electronics repair. Ciao for now, guys.